Hello. This quick video is to give you some background about calculating molar concentrations and why we care about molar concentrations in biology. So I want you to remember that a solution is a mix of a solvent, which is the liquid, and a solute, which is the solid that you want to dissolve in the liquid. So in this case, I would consider coffee the solvent, right? So the coffee water, and the sugar, the solute, the stuff I want to dissolve in there. And in biology, we make lots of solutions. You can even think of a cell as a solution. And the main unit used in chemistry is the mole. And not this cute guy. The mole is a defined number. So a mole is 6.022 times 10 to the 23. That's a whole lot of molecules. And don't let this intimidate you. This is just like saying you have a dozen eggs. If someone says, I have a dozen eggs, you know, they mean 12. If someone says, I have a mole of sodium, it means they have 6 times 10 to the 23 molecules. It's just a unit. I do love to throw in some science jokes, so there you go. All right, so when we're measuring solutions, we talk about concentration. And I want you to understand that when you see these brackets, they represent concentration. Okay? And sometimes we do a volume to liquid concentration. Sometimes we talk about a concentration in percents. But if we're talking about molarity, or this capital M, molarity, molar solution, stands for moles that we just learned about, 6.022 times 10 to the 23rd molecules per liter, right? So the number of moles of a solute dissolved in 1 liter of water equals a molar solution. So let's put this into a little bit more perspective. So we've talked about molecular weight. You may have not realized this, but when we talk about atomic weight, it's the same as molecular weight, right? And we get this from the periodic table. And remember, we talked about molecules, meaning you're putting at least a couple atoms together. Right? So if you look at the periodic table and you see chloride, right? The molecular weight of chloride is 35.45. Remember, the smaller number is the molecular number. So molecular weight, atomic mass, molecular mass. For us, they're all the same thing. Now, technically, mass and weight are different because weight has the influence of gravity, but us biologists are going to keep it simple this semester. Okay. The units for molecular weight is grams per mole. Okay. So chlorine, I keep calling it chloride, sorry, chlorine is 35.45 grams per mole. So when you have 6 times 10 to the 23rd molecules of chlorine, it weighs 35.45 grams. Right? Molarity, now you know, is moles per liter. And you can start to see how these have some similar units. When we're making a solution, we want to know how much of our molecule we need to dissolve in how much of a liquid, right? So it's solute, what's going to have a molecular weight, into our solution, which is going to have a volume. So for instance, let's pretend I weighed out 120 grams of chlorine. Okay, you can't really do that because you can't, but let's just pretend. And I put that into a half a liter. Okay, so this is my solution. I've got my solute, this is water, and my and my solvent. You love me and my technology. Okay, what is the molarity, the molar concentration of this thing that I just made? So the way you're going to do that is you're going to say, okay, I have 120 grams of chlorine in 0.5 liters of water. And I know that chlorine has 35.45 grams per mole molecular weight, right? And I flipped it upside down because I always want my units to cancel. So let me try to change color here. It's not going to let me. Oh. Alright, so I can cancel out my grams of chlorine. And if I do this math, I find out that I have a 6.77 moles per liter solution, which is a 6.77 molar solution. All right, so really all you need is to be able to figure out molecular weight and either be told the molarity that you want to get to, or based on some information for making the solution, you can figure out the molarity. So let's try a problem. What do you need to make a 1 liter, what do you need to make 1 liter of a 1 molar sodium chloride solution? So what I would like you to do is pause the video and try this. So the first thing you're going to do is figure out the molecular weight of sodium chloride, which we get off the periodic table. So for sodium it's 22.99, and for chlorine is 35.45. So sodium chloride is 58.44 grams per mole. A 1 molar solution is the same as 1 mole per liter. Okay, so we look at our two numbers and figure out how can we use this information. So if we line it up and say 54.44 grams per mole times 1 mole per liter, let's see, whoops. Then we can figure out that we need to measure out 54.44 grams of sodium chloride and mix that in 1 liter of water. And we're always going to use water as our solvent in biology. Okay? So this is what you'd write in your lab notebook. You'd go to the scale, you'd weigh this out, you'd mix it into the water until it dissolved. Try this one. What do you need to make a 0.5 liters of a 0.25 molar glucose solution? So go ahead and pause the video until you have this, and then you can come back and check your answers. So you first figure out the molecular weight of glucose, which is C6H12O6. So you get 6 times 12.01 plus 12 times 1.01 plus 6 times 16 equals 180.18 grams per mole. That's the molecular weight. Right? And I know that I want a 0.25 moles per liter solution. So I'm going to take 180.18 grams per mole. Remember, you always want to just put those units so they work for you. To a 0.25 moles per liter. Those cross out, and I get 45.045 grams per liter. But I only want to make a half a liter. So I take 45.045 grams per liter. And I multiply that by 0.5 liters. And again, my units cancel, and I tell my boss I need to measure out 22.52 grams of glucose and dissolve that in a half a liter of water. Okay, so if you keep your units so that they're canceling out, you're always going to get this math right. So where is molarity important in biology? Well, when we talk about the pH scale, we're going to talk about the moles per liter of hydrogen ions. When we talk about membrane potential, and this we get into more in cell biology, all these different ions have different molar values. And remember the M here is for millimolar. So it's millimoles per liter. And again, we measure, you can see in saliva and plasma, which is the liquid part of your blood, we'll measure different ion concentrations in their moles per liter, or in this case, millimoles per liter. So go ahead and review how to calculate molarity. You know how to get molecular weight off the periodic table. Watch your units so that they cancel out right, and you're good to go. All right, thanks.